Hello friends, welcome to next lecture in Engineering Mathematics 2. So in this video lecture we shall see few examples on directional derivatives, that is del f into n cap. So here we have solved around 4 problems. So please stay tuned with this video lecture. So before we begin with this lecture, I request you to please subscribe to this YouTube channel. Click the bell icon for the latest notification of the videos which will be uploaded on this YouTube channel. Follow us on Twitter, Instagram, and like our Facebook page, Mechanical Engineering Tutorials. The links are in the description below. So friends, let's begin with the video lecture.
Friends, in yesterday's class, we had discussed about the gradient, directional derivative, and unit vector to the normal to the surface. So in today's class, we will be solving examples on those results. As a first result, in today's class, let us solve examples on directional derivative. So please remember steps to be followed in calculating directional derivative. You will be given a surface, means an equation will be given in x, y, z. Then a particular direction will be given, means a vector will be given. So first step, you have to write the formula for del f or del phi. Then calculate del phi at a given point. Then given direction, you have to calculate unit vector, and then in the final step, directional derivative is dot product of del phi and n cap. I will illustrate in the following example. Now first one is about the norm. This is the example, we shall discuss it first. Find a unit vector normal to surface x y cube z square is equal to 4 at the point -1, -1, 2. Friends, here unit vector normal to the surface. So already you know that the gradient, that is del phi, is what? It is normal to the surface. It is a vector quantity we get. Just find a unit vector along that. That's all we have to discuss in this problem. So first step is the given surface denoted as f. Second step, calculate the partial derivative of f with respect to x, y, z. And you all know how to calculate partial derivatives. When you are differentiating with respect to x, keep other variables y and z as constants. Similarly, when differentiating with respect to y, other variables are to be treated as constants. Thus, dou f by dou x will give us y cube z square. Dou f upon dou y is equal to 3x y square z square. Dou f upon dou z means this will be constant here. X y cube will be constant and derivative of z square is 2z. Altogether I have written 2x y cube z. Next step is you are substituting these values in del f. So for that I have written formula for del f. Del f is what? Gradient. So del f is equal to I into dou f by dou x plus j into dou f upon dou y plus k into dou f upon dou z. So that gives I into y square z square plus j into 3x y square z square plus k into 2x y square z. So here at this stage what we got? We got a vector which is normal to given surface. What is the surface? Here this is the surface. Now the question is, you are asked to find unit vector normal to this surface. So just you have to find a unit vector. So for that we have to calculate this del f, that is normal vector at a given point -1, -1, 2. So it means in x, y, z substitute -1, -1, 2. So we get -4 minus 12 plus 4. And simplifying this, we get minus 4i minus 12j plus 4k. Now this is what now? This is normal vector to the given surface at a given point. Lastly, we have to calculate unit vector. Hence, unit vector normal to the surface is minus 4i minus 12j minus plus 4k. Now this vector is to be divided by its magnitude, square root of 16 plus 144 plus 16. So when you are writing the square of minus 4, square of minus 12, minus will become plus. So 16 plus 144 plus 16. From numerator, take out 4 common. So what remains? Minus I minus 3j plus k. Denominator also, you can take out 16 common outside the square root sign, which will be 4, and inside it is 1 plus 9 plus 1, and cancel common factor 4. So the final answer is 1 upon root 11 into bracket minus I minus 3j plus k. So this is the required answer. This is the unit normal vector to the given surface at a given point. Let us see the next example. Find the directional derivative of f of xyz is equal to xy square plus yz cube at the point 2 minus 1 1 in the direction of the vector I plus 2j plus 2k. Friends, in this problem you are asked to find directional derivative. So a surface is given, already it is denoted by f. A particular point is given where you have to find the directional derivative, and in what direction you have to find, that is given by a vector. So first step, formula you have to write. Del f is what? I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. Then I into dou by dou x, substitute for f, that is xy square plus yz cube plus j into dou by dou y of, that is f value only, plus k into dou by dou z of f value only. And partial derivatives you are all familiar with. First one, it will be I into y square, because other term will become 0. You are differentiating with respect to x. J into, it is 2xy plus z cube. And third term, k into, it is when you are differentiating with respect to z, first term becomes 0. So 3yz square. So I calculated first step del f. Next step, you have to calculate what given direction. N bar is I plus 2j plus 2k. Unit vector calculation all of you know. Formula for n cap is n bar upon magnitude of n bar. So I plus 2j plus 2k upon root of 1 plus 4 plus 4, that is 1 by 3 into bracket I plus 2j plus 2k. One more thing we need. We have to calculate del f at a given point. So del f at 2 minus 1 1 will be, del f already we have calculated. In that, for xyz you substitute 2 minus 1 1. So you get I plus j into minus 3 plus k into minus 3, and that gives I minus 3j minus 3k. Therefore, directional derivative is given by del f dot n cap is the definition of the directional derivative. Substitute for del f, it is I minus 3j minus 3k, and unit vector we have calculated dot 1 upon 3 into bracket I plus 2j minus 2k. Friends, here in dot product we have studied that you have to multiply the corresponding coefficients of I, J, K and add it. So it is 1 by 3, keep it completely outside. So here coefficient is 1, here also 1. 1 into 1 is 1. Minus 3 into plus 2, minus 6. Minus 3 into minus 2, it is minus 6. So the final answer is minus 12 plus 1, that is minus 11 upon 2 is the directional derivative. Example number 3. Find the directional derivative of f of x, y, z is equal to x square minus y square plus 2z square at the point P 1, 2, 3 in the direction of the line PQ, where Q is the point 504. Also calculate the magnitude of the maximum directional derivative. So this is a very important sum. First we have to calculate directional derivative. Second part is we have to calculate maximum directional derivative. Friends, here to calculate directional derivative, one step is what? Gradient formula you are writing, del f. Then there you are calculating partial derivative. Second step, dou f by dou x, dou f by dou y, dou f by dou z. Third step, what you are doing? Substituting those partial derivatives in del f. Then you get a vector normal to the surface. Then it is at the point you calculate, at the point 1, 2, 3. So you get particular vector. Then in this case, instead of giving you the direction directly, it is said that it is in the direction of the line PQ. So in 3-dimensional geometry, we have studied that to find out PQ, when P and Q are given by their coordinates, so there is a formula I will explain in the solution. Then finally you write find unit vector along PQ. Then what is the directional derivative? Del phi dot n cap. So let us go stepwise, because all together you may not understand that one. So first step, what I am doing is writing the formula for del f. It is I into dou by dou x of given function x square minus y square plus 2z square plus j into dou by dou y of the value of f and k into dou by dou z of the value of f. And partial derivatives already you are familiar with. So I into only 2x we get, j into only minus 2y we get, k into only 4z we get. Now calculate del f at a given point, that is 1, 2, 3, because it is said at the point. So at 1, 2, 3, when x is 1 it is 2i, when x is 2 it is minus 4i, when z is 3 it is 12k. So we got del f at a particular point. Next we have to consider the direction. So PQ bar, in vectors we have studied that PQ bar can be calculated as OQ bar minus OP bar. These are the position vectors of the point Q minus position vector of the point P. Friends, just remember here, if it is PQ bar, it is the terminal point minus initial point. If it is AB bar, what we would have written? OB bar minus OA bar. If it is MN bar, we would have written ON bar minus OM bar, like that. So OQ bar is what? So associate these with IJK, 5i minus 0j plus 4k, minus OP bar will be I plus 2j plus 3k, and subtraction of vectors is what? Add corresponding vectors, coefficients of the terms. So 5i minus I, 4i, 0 minus 2 minus 2j plus 4 minus 3, it is plus k, and this is our n bar. So n bar is not directly given in this problem. Now find a unit vector along this. N cap is equal to n bar upon magnitude of n bar, that's equal to 4i minus 2j plus k upon square root of 16 plus 4 plus 1. Thus n cap is 1 upon root 21 into bracket 4i minus 2j plus k. Therefore, directional derivative of f in the direction of n bar is del f dot n cap. This is our del f and this is our n cap. Just now we have calculated 1 upon root 21, keep it aside, and corresponding coefficients are multiplied here. 2 into 4, 8 minus 4 into minus 2 plus 12 into 1, that gives 28 upon root 21. Now there is another part in this problem. We have to also calculate magnitude of the maximum directional derivative. Friends, do you remember in my previous video under the note I had explained the maximum directional derivative will be along del f. So modulus of del f. The directional derivative of f is maximum in the direction of normal to the surface. Normal to the surface is our del f. Therefore, maximum value of the magnitude of directional derivative is modulus of del f. Modulus of del f is equal to modulus of 2i minus 4j plus 12k. That's equal to square root of 4 plus 16 plus 144 is equal to root of 164. Next problem. Find the directional derivative of phi is equal to xz upon x square plus y square at a point 1 minus 1 1 in the direction of n bar I minus 2j plus k. Straight away problem it is. There is no any complication. Only thing, the surface is given in the form of ratio of two functions. That's why this problem is important. Same procedure, formula for del phi, I into dou phi by dou x, j into dou phi by dou y, k into dou phi by dou z. Since calculation is bit lengthy in the partial derivative, so I have considered separately. Let us calculate dou phi upon dou x. In u by v formula, you just see here x is there in numerator as well as denominator. So I have to apply u by v formula. Friends, you all remember derivative of u by v. That is v into du by dx minus u into dv by dx upon v square. So I am applying that formula. In ordinary derivative we are applying that formula. All those formula are holding good for partial derivatives also. Okay, dou phi upon dou x. Denominator square, x square plus y square the whole square. Keep denominator as it is in numerator, x square plus y square. Derivative of xz, numerator with respect to x, it is only z, minus numerator xz, keep it as it is. Derivative of x square plus y square with respect to x, it is 2x. So z is common. Take it out. X square plus y square minus 2x square, and that will give z into bracket y square minus x square. You can combine x square and minus 2x square. So z into bracket y square minus x square upon x square plus y square the whole square. This is dou phi upon dou x. Next, dou phi upon dou y. Friends, here just see y term is only in denominator, but there is no term in y in numerator. So this is a reciprocal function. You all remember derivative of 1 by x is what? Minus 1 upon x square. Like that, what is derivative of 1 upon any function? It is minus 1 upon fx square into f dash of x. So I am applying that formula here. So dou phi upon dou y is xz is constant. Keep it as it is. Okay. Then into reciprocal function means 1 upon x square plus y square. Its derivative will be minus 1 upon x square plus y square the whole square into derivative of inside quantity with respect to y only, that is 2y. So finally it will be minus 2xyz upon x square plus y square the whole square. Here you could also apply u by v formula, then also you will get the same formula here. Okay. Next we shall see how to find with respect to partial derivative with respect to z. This is very simple because x upon x square plus y square becomes constant, kept aside. What remains is only z. So dou by dou z of z is x upon x square plus y square. So you got dou phi by dou x, dou phi by dou y, dou phi by dou z. Substitute in result number 1, you get del phi. Therefore, from 1, del phi is I into z into bracket y square minus x square upon x square plus y square the whole square plus j into minus 2xyz upon x square plus y square the whole square plus k into x upon x square plus y square. Now you have to calculate del phi at a point 1 minus 1 1. So wherever x, y, z are there, just substitute. When you substitute here, first term becomes 0. Second term calculations, just see, in place of x, y, z it is substituted. Finally it yields to 2 upon 4 and here k into 1 upon 2. So the final answer for this is, for del phi at a given point is half j plus half k. Now direction, what is the direction given? N bar. N bar is A bar, I think, sorry. So I minus 2j plus k. So I'll just denote for our convenience as n cap. N cap is equal to A bar upon magnitude of A bar, that is I minus 2j plus k upon root of 1 plus 4 plus 1. So that gives 1 upon root 6 into I minus 2j plus k. Friends, now the last step is what? You have to just find the dot product of del phi and n cap. That is your final answer. Therefore, directional derivative is given by del phi dot n cap. So del phi at a given point 1 minus 1 1 we have calculated, that is half I plus half j dot I minus 2j plus k upon root 6, 1 upon root 6, keep it aside, dot product of I into I, it is 1 and j, there is no k term here. So k term is not here. Just a minute. It is half j plus half k. I am sorry. So del phi dot del phi, by mistake I have written it as I, it should be read as j. I'll make the correction. So half j plus half k it should be. So half j into minus 2, that is minus 1, and half k into 1 is half. So the final answer is minus 1 upon 2 root 6. So this is the final answer for this problem. Friends, I have just given 2 problems as a home assignment. If you have followed these 4 problems, just give a try to solve these sums, and I have also given the answers for this, and you may send your solution on this email ID, anildeshpande@rediffmail.com. So first problem is find the directional derivative of x square yz plus 4xz square at 1 minus 2 minus 1 along 2I minus j minus 2k. Answer, you should get 37 upon 3. Second problem, find a unit vector normal to the surface x cube plus y cube plus 3xyz is equal to 3 at the point 1, 2 minus 1. Answer, here you should get minus I plus 3j plus 2k upon root 14. Thank you.